College Algebra. This is the last part of Lesson 3.3's notes. So we're going to start with Part C, which is the fundamental theorem of algebra. It says every function defined by a polynomial of degree 1 or more has a zero. Basically, this means it can be factored. So if you, and then it goes on to say, if you have degree n, then you have at most n distinct zeros. So that means you can have up to, like for this example here, you can have three zeros that are different from each other or fewer because it's degree 3. However, I've given you an equation there that when you factor it down, it only has one zero, which would be -1. So it's got x plus 1 as a factor 3 times. We say that x plus 1 has a multiplicity of 3, or the 0 has a multiplicity of 3. Then we get into example 5, and it says that we're going to find a function that has degree 3 that has the following zeros. And we have this right here. This basically means we have this ordered pair, -1, 6, that is on the curve. All right, so we're going to start with f of x equals, we're going to have some a value, so that could be a shrink or a stretch. It could be negative or positive. We're going to use the ordered pair -1, 6 to help us find that a value. For each 0, we're going to have a factor. So for -3, we'll have x plus 3. For -2, we'll have x plus 2. For 5, we'll have x minus 5. Okay, before we go any further, you're going to plug in the 6 for your y and the -1 for your x. And so we go from here and we plug those values in. And what we're going to do is find a first. And if we divide both sides by -12, we'll have a equals -1/2. From here, they're going to ask you for these in general form, basically, which means you're going to have to multiply them out. So we're going to have to FOIL and so forth. Okay. It's just looking back through my work, making sure that I don't have any mistakes, and so far it looks pretty good. So okay, I'm FOILing out the first two terms, or the first two factors. And then I'm going to factor or multiply everybody by x. And then by a -5. Okay, so these have added to 0, minus 19x minus 30. And there's our polynomial. All right, for example B here, 4 is a 0 of multiplicity 3. That means we have x minus 4 cubed. And I forgot one little thing. I need to put my a in front of here so I can figure out if it's shrunk or stretched or reflected, that kind of thing. This is the ordered pair to -24. So I'm going to find my a value first, so it works the same way as the last one. So I put in my 2 and my negative 24. That'll be a negative 8. And divide 24 by a negative 8, and I'll see that a is 3. So from here again, we're going to keep on going, and we're going to FOIL and get it all multiplied out. So I'm distributing the x through, and then the minus 4. Okay, make sure I've got everything here. I don't want to make any silly little mistakes. All right, I think we're good. Let's see, 48 times 3 was 144. And 64 times 3, don't have a calculator with me, so 192. And there's your equation. Okay, so there's a few practice problems there for you to play with. And then we're going to get into conjugate zeros. So the way conjugate zeros work, some polynomials have zeros that are real, and also some zeros could be imaginary. So if they're imaginary numbers or complex numbers, they always come in conjugate pairs. So for our first one, we have the 0, negative 4, and we also have 3 minus I. So from there, I can deduce that because 3 minus I is a 0, 3 plus I is also a 0. Now what we're going to do is we're going to put this back in the form of a polynomial. We want to go ahead and write it all multiplied out. So with these, though, you don't have to worry about that a coefficient in front. You can just forget that. Just assume a is 1. For the 0, 4, we have x minus 4. So every time we have a 0, we subtract from x. So I'm going to take x minus 3 minus I. And x minus 3 plus I. So those are zeros as well, and they get put back in as factors. And I do that again by subtracting from x. And to do x minus 3i let's do this first. So I distributed my negative. To multiply those together, I'm going to set up a table. And go ahead and do the product. So x squared minus 3x ix minus 3x 9 minus 3i minus ix 3i minus I squared. And so with these, since they're conjugates, you're going to have pairs add to 0. So these add to 0 and these add to 0. So I'm left with x squared minus 6x and then minus a negative 1 from negative I squared. So that makes 1 plus 9 is 10. And then I'm going to be multiplying that by x minus 4. You can do a table again for this, or you can just multiply it right through. I think since I've got it set up here, I'll go ahead and do a table. And it's pretty easy with the times table. It'd be a positive, wouldn't it? And then minus 40. So that is x to the third minus 10x squared plus 34x minus 40. Okay. So you're going to find with this lesson there's just a lot of work in multiplying out your polynomials and stuff from factored form. That's kind of the worst that it gets. All right, on example 7, you have x to the fourth minus x to the third minus 17x squared, 55x minus 50. And we're supposed to find all of the zeros given that 2 plus I is a 0. So we know 2 plus I is a 0, so that means 2 minus I is a 0. So basically you already have 2 of the 4 zeros, and you have to find the other 2. There's a couple different ways you can do this problem, and I think since I'm not here teaching this to you, I think you'll do better with synthetic division. The other way is with long division. So I'm just going to go ahead and set this up with synthetic. Let me make sure I've got all my coefficients in there. Okay, I'm going to bring down my 1, 2 plus I, add 1 plus I. I'm going to multiply those together, so I'm just going to have some workspace down here. Let's see, that's going to be 3I plus I squared. So 1 plus 3I. That'll give me negative 16 plus 3I. Okay, so negative 32 minus 16I, 6I, plus 3I squared. That'll give me a negative 35 minus 10I. Let me switch colors here, and that will give me 20 minus 10I, and I'm going to take that times 2 plus I. Now we should be getting a remainder of 0 because 2 plus I was a 0, so we know the remainder has to be 0, and that's coming out just fine. Okay, so now what we're going to do is we're going to do synthetic division again. So we need to now consider that 2 minus I is also a 0, and what we're going to do is bring it down as a degree. So we're going to use these as our coefficients across the top. Let's see if I can get some space here. That's really crowded. Let me try this again. So we want to do 2 minus I. There we go. And then 1 plus I, minus 16 plus 3I, and 20 minus 10I. And okay, here we go. So we bring down the 1. 2 minus I, that gives us 3. And then that will be 6 minus 3I, which gives us negative 10. And that will give us negative 20 plus 10I, which is 0. And so this line here, it was an x to the fourth polynomial, so this would have brought it down to x to the third. So this is going to be x squared plus 3x minus 10. Well, from there I can simply just factor it. And my other zeros then would be negative 5, and 2. So this polynomial has 2 real zeros, negative 5 and 2, and then also 2 imaginary zeros. And we know at most we can have 4 zeros, so we found all of them. All right, that is the end of your notes. I'll see you guys back tomorrow.